Hi everyone, it's a pleasure to meet you again here. From now on, I will give you a lecture from the beginning of the statistical analysis to the level you can complete your paper. The contents of the lecture are in my book, but the book translated into English has not been published yet. So, I will explain the contents in English. The title of the book is Proper Method of Statistical Analysis for Dissertation. As you saw in the first video introduction, this book has 3 parts in total. Now that this is the first lecture, let's take a look at the contents of the book. Part 1 is the contents of research methodology. Because we do not have enough time to cover the entire contents of this research methodology, I briefly explain what you need to write your paper. Part 2 will cover everything from basic statistical knowledge to advanced regression analysis. In fact, even if you study this part, there is no problem in writing a thesis. Part 3 describes the structural equation model. In recent paper, it is most necessary analysis method. I described in SPSS AMOS program. I will going to start with the basic of how to deal with the program and how to deal with advanced analysis. SPSS AMOS has the advantage of linking files with SPSS Statistics. Therefore, it can be very useful. There are many other programs for structural equation model, but it is a GUI environment, so it is very easy to learn and support advanced analysis, so it is appropriate for beginner. Now, the part that starts today is hypothesis and significance level. Why do we first learn the hypothesis and significance level? Let's think about why we do research. Why do you study? The purpose of the study is to find out what the public think and cannot think of. It is to find something. It is meaningless if everyone knows what you have to look for. In general, research is to find things that are unknown or different. And the researcher verifies it. Verification is done on a hypothetical basis. Verification is based on the significance level to confirm whether it's right or wrong. Therefore, the hypothesis and significance level should be known first. If a researcher has hypothesized that he or she should know something, then a measurement should be made to do the research. At this point, the scale is as important as the hypothesis. We will be learning about the scale next time. The scale is the basis for constructing the data when making measurement. The reason why the scale is important is because the analytical method that can be selected depends on which scale the researcher uses. Applicable methods are divided according to the type of data obtained. Once the scale to be used for the study is determined, the next step is to collect data necessary for the study. We need to get the data to analyze. But how do you make the questionnaire? Data collection for research explains how to make questionnaire, which is the method collecting data. If the questionnaire is made, we should get the data now. Since it is not possible to target the entire population, a representative sample should be extracted, and we get data from this sample. After obtaining the data, we need to analyze the obtained data and make it in a format that the computer can understand. We call this coding. Chapter 6 will describe statistical analysis method for analyzing data. It will be an overview of the analysis method described in my book. It will also be time to see how the statistical analysis method is used. Now, let's go into the first chapter. The first thing to learn is a hypothesis. The process of research is the process of collecting data about a fact or phenomenon, and then obtaining the rule or result inherent in that fact or phenomenon. This is the reason for doing research. In other words, the first is to show some objection. The second is to verify that the researcher's claims are different from the actual fact. And the third, to find any new variables. The hypothesis is expressed as follows. Using the initials of the hypothesis, H, distinguish between this is the same as true and this is different from the truth. For example, the 300 milliliter label on the beverage can is right or not 300 milliliters. The hypothesis is divided into the null hypothesis and research hypothesis. An research hypothesis is also called an alternative hypothesis. You can just memorize the meaning of the name of the null hypothesis and the research hypothesis. But if you understand why these names have been given, you can easily distinguish and memorize them. The reason why the researchers do research is to verify that everyone trusts is wrong. Now imagine that there is a beverage labeled 300 milliliters. By the way, if a researcher studies the correctness of the 300 milliliters written on the beverage, the researcher would like to verify that this beverage is not 300 milliliters. The reason why we think so is simple, because if 300 milliliter is right, it is not necessary to do the research. The research hypothesis is that the researcher has claims such as it is not what it is. Now, let's think the opposite. Do you need to study if the 300 milliliters is right? The value of the study is 0. Why do I have to spend time and money doing research? Thus, the prefix null is added to the hypothesis as a null hypothesis, meaning worth of 0 in this study. The key point is this. If you need to do some research, it is a research hypothesis. And if you do not need to study, it is null hypothesis. As shown in the table, the null hypothesis is expressed by adding 0 to the hypothesis heading letter H, since the research value is 0, and the meaning is a hypothesis that is universally right. In addition, research hypothesis is expressed as an opposition to 0 used in the null hypothesis with 1 attached, which means a hypothesis that make a new claim that is opposed to what is already considered right. If these two hypotheses are established, the study is to determine whether H0 is true or H1 is true. So, what are the criteria for making this judgment? We need two criteria to judge which hypothesis is right. This criterion is called the significance level. This significance level is usually expressed as a p-value using the initial of probability. Generally, we use the significance level as a p-value, but there are other values as well. But I explain the p-value first. Since the p-value is a ratio, a range of 0 and 1 is defined, which is convenient to explain and understand. after comparing the result from the research with the significance level, we decide whether to reject or support the null hypothesis. For example, if the significance level p-value is 0.05. In fact, this means that the null hypothesis is validated at 95%. The graph of the normal distribution is as follows. The graph spread to the left and the right around the mean. The whole is 100%. A p-value of 0.05, which is a confidence level of 95%, means that the amount of beverage measured around the mean is 95%. Since the research hypothesis proved that it is not 300 milliliters, the researcher can verify that the amount of measured beverage is farther from the average than 5% and is correct. Of course, in this case, less is a problem for everyone, and more is not a problem. Just this case focus only 300 milliliters and not 300 milliliters. I wish I could have more at the same price. Who would not? If the analysis result is p is 0.03, p less than 0.05, the research hypothesis is adopted and null hypothesis is rejected. On the contrary, p equals 0.07, p greater 0.05, the alternative hypothesis cannot be adopted and the null hypothesis is maintained. Future video will have various values with p-value. These are also significant. T-value, F-value, and chi-square value are calculated. The result of other numerical values are displayed according to the needs of analysis, such as t-test, analysis of variance, ANOVA, regression, and cross-tabulation analysis. By the way, look at this table closely. There is a common one of these. That's the p-value. This p-value is more intuitive and easier to judge than any other unspecified value. For example, if the absolute value of t is greater than 1.96, the p-value is less than 0.05. Also, if the absolute value of t is greater than 2.58, the p-value is less than 0.01. And there are expressions such as in article and various journals. Of course, we do not have to memorize this, because the researcher decides and annotates it. In general, the number of asterisks indicate the significance level of p-value. One asterisk denotes the significance level of 0.05. Two asterisks denote the significance level of 0.01, and three asterisks denote a p-value of 0.001. Now you have learned about hypothesis and significance level of Chapter 1. Thank you for watching. If you have any question in the process of studying on YouTube, please feel free to ask me. You can leave a comment, email, or visit my homepage. Thank you.